Good evening, and welcome back to Deep Sleep Science. Tonight, as you settle into the quiet comfort of wherever you rest, your brain is already beginning something remarkable. Somewhere behind your closed eyes, a guardian system is waking, one that has sheltered every meaningful moment you have ever lived, the memories you treasure, the lessons gathered across years, the tender fragments that define your story. They are all being tended to right now, in ways science is only beginning to understand. You do not need to hold on to anything tonight. You do not need to remember a single word. Simply allow the rhythm of these ideas to wash over you, like warm rain against a window pane, carrying you wherever rest wants to take you. This quiet sanctuary grows each time a resting mind discovers it. A gentle subscribe or like helps another sleepy soul find this peaceful corner of the night. One soft moment, one tranquil heart at a time. Let your shoulders drop now. Let the weight of today drain slowly from your muscles like warm water flowing downhill. Tonight, we will wander through 100 soothing psychology facts about how your brain protects memories while you rest. From the silent guardians buried deep in your neural pathways to the delicate choreography of sleeping brainwaves, from the emotional healing that unfolds in darkness to the gentle art of releasing what no longer serves you. There is nothing to solve here, nothing to chase, only the slow, sweet drift toward understanding and sleep. And now, we begin. Memory is, at its deepest level, the substance of who you are. Every preference you hold, every skill that feels second nature, every emotional response that arises without your asking. All of these were shaped across countless nights of sleep-dependent consolidation. Research from 2025 confirms that autobiographical memory, the collection of experiences forming your personal narrative, undergoes active integration while you rest, weaving new moments into the existing fabric of selfhood. Without this nightly weaving, each morning would arrive, disconnected from the last, like threads slowly added to a tapestry that only grows richer with time. Your sleeping mind quietly stitches yesterday into the story of who you are becoming. The memories you carry shape how you perceive tomorrow far more than you might realize. Past experiences, consolidated during countless nights of sleep, build expectations and predictions that color how you interpret new situations. Your brain's internal model of reality, assembled through sleep-dependent processing, determines what you notice, what you overlook, what draws you forward, what makes you pause. You see the world through a lens crafted by consolidated memory, each night refining the glass a little more. Like a river carving its path through stone, your sleeping memories quietly shape the landscape through which tomorrow's experiences will flow. Releasing memories that no longer serve you is not a failure of your brain. It is among its most generous gifts. Sleep gently fades trivial details while preserving meaningful patterns. This thoughtful forgetting prevents your mind from becoming cluttered with irrelevant information that would crowd out what truly matters. What fades during sleep was never meant to remain. What persists is what your brain, in its quiet wisdom, chose to keep. Like autumn trees releasing their leaves so that new growth may come, your sleeping mind lets go to make room for what is still to come. Your emotional memories, processed tenderly during REM sleep, shape the emotional terrain of your inner world. Joys consolidated during rest become wellsprings of resilience. Painful experiences, reprocessed to soften their edges, gradually lose their power to wound. Over many nights of healthy sleep, your brain reshapes your emotional relationship with the past. What once caused sharp distress may eventually become merely a quiet chapter in your story. Still present, but no longer piercing. Like stones in a stream slowly smoothed by water, your difficult memories are gentled by the patient current of sleep. The memories formed during childhood, when deep sleep is most abundant, often feel particularly vivid and emotionally rich. This is more than simple nostalgia. Young brains genuinely consolidate memories with a different intensity, perhaps because every experience is so wonderfully new. As sleep architecture shifts across the years, the texture of consolidation changes too. Yet every age benefits from this nightly memory tending. Whether you are young or have lived many decades, sleep transforms experience into the architecture of self. Like a garden that blooms differently in each season, yet always grows. Your memory system adapts and endures throughout the whole of life. Dreams sometimes reveal answers your waking mind quietly overlooked, as your sleeping brain explores possibilities beyond the reach of ordinary logic. Freed from the assumptions of conscious thought during REM sleep, your mind makes unusual associations that occasionally yield genuine insight. Throughout history, scientific discoveries and creative breakthroughs have emerged from the dreaming state. The sleeping mind, working gently with memories and unresolved questions, sometimes finds what the waking mind missed, like a key turning in a lock you did not know existed. Inspiration arrives softly on the tide of rest. Memory consolidation connects you to an ancient lineage of human experience. The same processes tending your memories tonight have operated in human brains for hundreds of thousands of years. Your ancestors depended on learning from experience and remembering what sustained them. Sleep-dependent consolidation is ancient, fundamental, woven into the fabric of what it means to be human. Every person who has ever lived transformed experience into memory through sleep. You participate in something timeless, joining countless generations in the nightly work of becoming, like a song passed from voice to voice across millennia. Your sleeping brain carries forward humanity's oldest tradition. The quiet hours of night, when memory transformation occurs, represent sacred time for your brain, in darkness and stillness, without the demands of waking life. Your mind performs essential maintenance and integration. Sleep is your brain's workshop, where the raw material of experience is refined into something more lasting, more useful, more deeply yours. What seems like passive rest is actually invisible craftsmanship that makes tomorrow possible. Like a master artisan working by candlelight, your brain shapes memories in the gentle hours while you are unaware. Your memories are not perfect recordings, yet that is not their purpose. They are designed to be useful rather than precise, to help you navigate future situations based on past patterns. Sleep's consolidation process favors usefulness over accuracy, extracting meaning over preserving every detail. This is why specific moments often blur together over time, while the emotional tone and general lessons persist clearly. But this flexibility also permits growth, learning, and adaptation. Like a compass that points toward meaning rather than coordinates, imperfect memory guides life rather than merely archiving it. Research from 2025 reveals that place cells in your hippocampus, the neurons that map physical spaces you have visited, replay their firing sequences during sleep. When you explored a new neighborhood, or walked through an unfamiliar building today, those spatial neurons will rehearse the same pathways tonight, strengthening your internal map. This spatial memory consolidation helps you navigate the world more fluently tomorrow without conscious effort. Like invisible cartographers working through the night, your place cells quietly redraw the maps you will use when morning arrives. The boundary between waking consciousness and sleeping awareness is softer than most people imagine, with memory processes operating gently across both states. Quiet waking rest supports some degree of consolidation. Drowsy moments before sleep and the slow emergence after waking both involve memory processing. Even daydreaming may serve consolidation functions. Your brain does not wait for deep sleep to begin its work. It is always processing, always tending. But sleep provides the optimal environment. Uninterrupted time and unique neurochemical conditions, where memory transformation flourishes most fully, like a river that flows constantly but deepens in the valley. Consolidation is always present, yet finds its greatest depth in sleep. We sometimes speak of sleeping on a decision, sensing intuitively that rest will clarify our thinking. Research supports this intuition. Sleep helps integrate new information with existing values and knowledge, leading to more balanced choices. The sleeping brain weighs possibilities, considers implications, and often arrives at conclusions that feel surprisingly clear upon waking. Your unconscious mind, working patiently through the night, offers a perspective your waking awareness alone might have missed, like fog lifting slowly from a valley to reveal the landscape beneath. Sleep dissolves confusion and lets the shape of a good decision emerge. Memory consolidation during sleep creates continuity across days, linking today to yesterday and yesterday to the week before in an unbroken chain of experience. Without sleep to consolidate your experiences, each day would stand alone, disconnected from those surrounding it. Sleep weaves the thread of continuity through time, creating the narrative coherence that forms a life. Your story exists because sleep connects its chapters, gently binding moments into meaning across the years. Like pearls strung on a single silk thread, each day's memories are held together by the quiet work of sleep. Some philosophers have suggested that memory is what makes personal identity possible. You are the same person as yesterday because you remember being that person. If this is so, then sleep is essential to identity itself. Each night's consolidation maintains the thread of self across time. You wake as yourself because sleep preserved yesterday's version of you and wove it together with today's experiences. Identity persists through the transformative work of sleeping memory consolidation. Like a flame that is never the same fire, yet always the same light. Your sense of self is continuously renewed by sleep. The memories formed in the company of others are often consolidated more deeply than memories formed in solitude. Social experiences, shared conversations, collective laughter. These engage emotion and attention in ways that mark memories as significant. Sleep consolidates not merely individual experiences, but also your social bonds, your relationships, your sense of belonging within communities. Memory consolidation makes you not merely an individual thinker, but a social being, connected to others through shared, remembered experience. Like roots intertwining beneath a forest floor, your social memories create invisible bonds that only grow stronger with each night's rest. New research from 2025 exploring epigenetic memory markers suggests that certain experiences may leave biochemical traces that persist across cell divisions. While this field is still emerging, Early findings indicate that significant emotional or learning experiences can alter gene expression patterns in brain cells, and that sleep may play a role in stabilizing these changes. Your memories may be encoded not only in synaptic connections, but in the very chemistry of your neurons, like words etched gently into wood rather than written in sand. Some memories may find permanence at levels deeper than we previously imagined. The default mode network, a brain system that activates during rest and quiet reflection, plays a fascinating role in memory consolidation. This network, connecting hippocampus, posterior cortex, and prefrontal areas, becomes active when you are not focused on external tasks. During sleep, particularly during lighter stages and REM, the default mode network shows heightened activity and stronger internal connections. This system appears to support the consolidation of personal memories and the integration of new experiences into your life narrative, like an inner storyteller who speaks only when the outer world grows quiet. Your default mode network weaves your life story while you rest. Your sleeping brain performs a kind of predictive processing, using memory consolidation to prepare you for likely future scenarios. By extracting patterns from past experiences, your mind builds models of how the world works that help you anticipate what might happen next. Sleep strengthens these predictive models, making them more accurate and reliable. When you wake, you carry not merely memories of past events, but enhanced intuitions about future possibilities. Sleep makes you not merely remember more clearly, but anticipate more wisely. Like a gardener who reads the soil and sky to know what the season will bring. Your sleeping brain reads the past to prepare you for tomorrow. The corpus callosum, the bridge connecting your brain's two hemispheres, facilitates memory consolidation by allowing both sides to communicate during sleep. Memories initially stored in one hemisphere can be shared and integrated with information held in the other. This dialogue between hemispheres during sleep helps create unified, coherent memories from initially scattered information. Your brain's two halves work together through the night, comparing perspectives, integrating fragments, assembling complete pictures from partial pieces, like two musicians playing different melodies that gradually merge into harmony. Your hemispheres collaborate in sleep to create memories that feel whole. Physical movement during the day enhances sleep-dependent memory consolidation that night. Exercise increases growth factors that support brain plasticity, improves sleep quality, and appears to prime the brain for more effective consolidation. Studies show that people who move regularly demonstrate stronger memory consolidation during sleep compared to those who remain sedentary. The relationship flows both directions, as sleep is also essential for recovering from physical activity and consolidating motor learning from practice. Like a dance between effort and rest, movement and sleep form a complementary rhythm, supporting both body and mind. Research from 2025 on the gut-brain axis suggests that your microbiome may influence sleep-dependent memory consolidation. The bacteria in your digestive system produce neurochemicals that can affect brain function, including neurotransmitters involved in sleep regulation. Emerging evidence indicates that a healthy gut microbiome supports better sleep quality, consequently, more effective memory consolidation. The connection between your gut and your sleeping brain is a frontier that science is only beginning to explore. Like an underground spring feeding a garden above, your microbiome may quietly nourish the memory processes that flourish during sleep. The sleeping brain's memory work is so intensive that brain metabolism during certain sleep stages approaches or even exceeds waking levels. Your brain is not simply resting during sleep. It is actively working, consuming energy, performing intricate computations. This intensive activity is why sleep deprivation is so harmful and why your brain insists on sleep even when it seems inconvenient. Memory consolidation is metabolically demanding work that cannot be postponed indefinitely. Your brain will eventually require sleep because this work is too essential to delay. Like a furnace that burns hottest when the house is quietest, your brain works hardest in the stillness of night. Individual memories are not isolated fragments. They exist in networks where related memories connect to one another. Sleep strengthens not merely individual memories, but also the links between related ones, building webs of meaning. This is why sleeping after learning often leads to insights about relationships between concepts that were not obvious during the day. Your sleeping brain is connecting scattered points, finding patterns, constructing structures of understanding from separate pieces of information. By morning, knowledge feels more integrated, concepts more connected, understanding deeper, like a spider weaving its web strand by strand in darkness. Your sleeping mind builds networks of meaning you will use when daylight returns. Memory consolidation during sleep follows a pattern researchers describe as prioritize and protect. Memories tagged by emotion, relevance, or repeated exposure receive preferential strengthening. Simultaneously, these valued memories are shielded from interference by new learning. Sleep essentially safeguards significant experiences while remaining flexible about trivial details. This explains why you might vividly recall a meaningful conversation but forget what you ate for lunch 3 days ago. Like a librarian who carefully shelves rare volumes while recycling yesterday's newspapers. Your brain manages its limited resources with quiet intelligence. The relationship between sleep and memory is not purely beneficial in every case. Sometimes sleep can strengthen memories we would prefer to soften, such as traumatic experiences or persistent intrusive thoughts. However, research into targeted reactivation and other techniques is exploring whether we might eventually learn to selectively ease problematic memories during sleep. This possibility, still largely experimental, could one day transform how conditions like post-traumatic stress are treated, like learning to tend a garden by choosing which seeds to water and which to leave dry. The science of sleep memory may one day offer us gentle choices about what we carry forward. So where does memory go during sleep? The answer has been unfolding quietly through these facts. Memory does not go anywhere, and yet it goes everywhere simultaneously. It diffuses throughout your brain, integrates with existing knowledge, becomes part of your neural architecture. Memory does not move to a single location. It becomes you. Sleep facilitates this transformation from external experience to internal essence, from what happened to who you are. Like rain dissolving into earth to nourish roots you cannot see, your memories dissolve into the substance of your being during sleep. Let yourself settle more deeply now. Feel the soft weight of your body pressing into wherever you rest. Notice the places where your skin meets fabric, where warmth has gathered beneath you, where gravity holds you with patient, invisible hands. Your breathing has found its own rhythm. You do not need to guide it. Simply observe how each inhale arrives like a gentle wave, and each exhale carries something away. Perhaps a thought, perhaps a tension, perhaps nothing at all. somewhere inside you. Your hippocampus is already beginning its nightly tending, gently sorting through the moments of your day, choosing what to preserve, what to release. You can trust this process completely. It has been caring for you since the very first night of your life. Let your jaw soften. Let the muscles behind your eyes release. There is nowhere else to be but here, held by darkness, held by silence, held by the ancient rhythm of rest. We continue drifting. Your brain prioritizes emotional memories during sleep consolidation in ways that reflect deep evolutionary wisdom. When an experience triggers a strong feeling, whether warmth, surprise, or unease, your amygdala releases neurochemical signals that enhance memory formation. Research from 2025 confirms that emotionally significant memories receive stronger consolidation during sleep than neutral ones. Your brain interprets these chemical markers as signals that this experience matters, remembering what brought safety, what brought nourishment, what brought connection. All of this would have been essential for survival across millennia, like a river that carves deeper channels where the current runs strongest. Your emotional memories create the deepest pathways in your sleeping brain. REM sleep, the stage where your most vivid dreams unfold, plays a distinctive role in memory that differs from deep sleep. While slow-wave sleep excels at strengthening factual knowledge and practiced skills, REM sleep appears specialized for processing emotional memories and weaving creative connections. During REM, your brain reaches levels of activity comparable to wakefulness, yet the neurochemical environment is entirely different. Norepinephrine, the stress chemical, drops to nearly undetectable levels. This unique state allows your brain to revisit emotional experiences from the day without the accompanying stress response, gently softening the sharp edges of difficulty. Like a healer who works only by moonlight, REM sleep tends your emotional wounds in conditions uniquely suited for repair. Dreams and memory consolidation share an intimate relationship that researchers continue to explore. Dreams often incorporate elements from recent experience, people you encountered, questions you pondered, emotions you felt. According to research published in 2024, dreams may serve as a form of overnight emotional therapy, allowing your brain to work through the day's experiences in a safe, protected space. During REM sleep, your mind makes novel associations between distant memories, potentially sparking creativity and fresh understanding. Some theories suggest that the strangeness of dreams reflects your brain testing different ways to link memories together, trying various combinations to discover meaningful patterns, like a painter mixing unexpected colors to find the perfect shade. Your dreaming mind experiments freely with memory's raw materials. When emotional memories are consolidated too powerfully, the result can sometimes be distressing. This is what may happen in conditions where unwanted memories become overstrengthened during sleep, returning again and again with undiminished intensity. Research from 2024 shows that disrupted REM sleep can interfere with the natural softening of difficult emotional memories, potentially contributing to persistent distress. Understanding this relationship has opened new avenues for therapeutic approaches that work with sleep rather than against it. Like a gardener learning when to prune and when to let grow, science is discovering how to gently guide the emotional consolidation that happens during sleep. The emotional color of a memory influences not merely whether it persists, but how it transforms over time. During REM sleep, when norepinephrine levels are at their lowest, Emotional memories undergo reprocessing in this uniquely calm neurochemical environment. The informational content of the memory, what actually occurred, can be preserved and even strengthened, while the emotional charge, how intensely it affected you, can be gradually reduced. This is why difficult experiences often feel less raw after a good night's rest. Research confirms this emotional recalibration during sleep is essential for maintaining psychological balance. Like a photograph that keeps its image while its colors slowly soften with age. Your emotional memories retain their meaning while losing their sting. Sleep's role in emotional processing extends deeply into your social intelligence. Sleep consolidates memories of social interactions, allowing you to learn from experience who offers safety. How to read subtle emotional signals, and which approaches to connection serve you well. Studies show that sleep-deprived individuals struggle more with recognizing emotions in others and navigating social situations. They misread expressions, overlook subtle cues, and find it harder to regulate their own emotional responses. This happens partly because REM sleep, which processes emotional memories, is essential for social learning. Without adequate REM sleep, you cannot effectively learn from social experiences or calibrate the emotions that guide your connections. Like a musician who needs silence between notes to hear the melody, your social brain needs sleep to make sense of the complex music of human interaction. Research from 2025 has revealed a phenomenon called REM rebound, where your brain compensates for lost REM sleep by entering REM more quickly and spending more time there during subsequent nights. After particularly emotional days, this rebound effect appears even more pronounced, suggesting your brain recognizes the increased need for emotional memory processing and adjusts accordingly. Your sleeping brain is not rigidly following a program. It is responsive, adaptive, prioritizing the processing that matters most based on what you experienced while awake. Like a wise body that sends more healing resources to its deepest wound, your brain directs extra REM time toward the emotions that most need tending. Your sleeping mind performs what researchers call overnight emotional recalibration, a process where the emotional weight of the day's experiences is carefully adjusted. Memories that seemed overwhelming in the moment may feel more manageable after sleep. Minor irritations that loomed large in the evening often feel trivial by morning. This is not distortion. It is your brain assigning appropriate emotional weight to experiences based on their actual significance, rather than the heightened reactivity of a tired mind. Sleep provides perspective, restoring proportionality to your emotional landscape, like a scale that finds its balance only when left undisturbed. Your emotions find their true weight during the stillness of sleep. Dreams may function as a form of pattern completion, where your sleeping brain fills in gaps and extends partial information into more complete understanding. When you encounter fragments of a problem during the day, your dreaming mind may continue assembling those pieces, sometimes arriving at solutions or insights that your waking consciousness could not quite reach. Studies from 2024 show that people who dream about a learning task demonstrate greater improvement afterward. Your dreaming mind is not merely replaying experience. It is actively building upon it, extending what you know into what you might understand. Like a river that finds its way around obstacles by flowing into every available channel. Your dreaming brain explores possibilities your waking mind might never consider. Recent research into fear extinction during sleep suggests that your brain can gradually weaken associations between neutral experiences and fear responses while you rest. When you learn that something previously frightening is actually safe, sleep helps consolidate this new understanding, gradually replacing the old fear association with the updated information. This process appears to depend on both REM sleep and the prefrontal cortex working together to overwrite outdated emotional responses. Over time, with adequate sleep, many fears naturally diminish as your brain consolidates evidence of safety. Like morning sunlight slowly warming a room that felt cold in the dark, sleep gently warms the places in your memory where fear once lived. Positive emotional memories, when consolidated during sleep, become sources of lasting resilience. Research from 2025 shows that sleep preferentially strengthens memories associated with positive emotions in ways that support psychological well-being. People who sleep well after joyful experiences retain the warmth and detail of those moments more vividly over time. This positive memory consolidation appears to build a kind of emotional reservoir that you can draw from during difficult periods. Your sleeping brain is not merely filing pleasant memories. It is constructing a foundation of emotional strength. Like a tree whose roots grow deepest where the soil is richest, your resilience is nourished by the positive memories sleep tends most carefully. Emerging research suggests that music heard during emotional experiences can enhance the consolidation of those memories during sleep. When a particular melody accompanies a meaningful moment, hearing that same melody during sleep may reactivate and strengthen the associated emotional memory. This connection between music, emotion, and sleep-dependent consolidation hints at the deeply intertwined nature of sensory experience and memory formation. Your brain does not store memories in isolation from the sensory world that accompanied them. Sound, emotion, and memory are woven together in ways that sleep carefully maintains. Like a song that carries you back to a specific moment the instant you hear it, your brain preserves the music of memory alongside the memory itself. Dreaming about a learning experience predicts better performance on that material afterward. In studies where participants learned to navigate virtual environments, those who later dreamed about the task showed measurably greater improvement compared to those who did not. Your dreaming mind appears to be actively rehearsing and refining new skills and knowledge, not merely reviewing them passively. The strange, surreal quality of dreams may actually reflect your brain, testing different approaches and connections, experimenting with possibilities that strict waking logic would never permit. Like a musician who improvises freely in private practice to discover new techniques, your dreaming brain plays with memory to find what works best. The near absence of norepinephrine during REM sleep creates conditions uniquely suited for emotional healing. This stress chemical, which keeps you alert and reactive during waking hours, virtually disappears during your most vivid dreaming periods. In this calm neurochemical bath, your brain can revisit emotionally charged memories without re-triggering the stress response that originally accompanied them. Over repeated nights of healthy REM sleep, this process gradually disconnects the emotional intensity from the factual content of difficult memories. The event is still remembered, but it no longer activates the same distress. Like a wound that heals best when left undisturbed, your emotional memories heal most effectively in the neurochemical calm of REM sleep. The relationship between sleep, emotion, and memory becomes especially evident in conditions like persistent low mood and chronic worry. These states often involve both disrupted sleep and difficulties with memory. Research suggests this connection is not coincidental. When REM sleep is fragmented, emotional memory processing suffers, potentially contributing to the negative thought patterns that characterize these conditions. Conversely, improving sleep quality often brings improvements in both mood and memory. The intimate connection between restful sleep, emotional balance, and healthy memory consolidation reveals why tending to your sleep is one of the most effective ways to tend to your overall well-being. Like three streams that merge into a single river, sleep, emotion, and memory flow together toward the same destination. Sleep helps consolidate memories of social pain and rejection in ways that gradually reduce their emotional impact. Research from 2025 shows that the brain regions processing social exclusion overlap significantly with those processing physical discomfort, and that sleep-dependent emotional processing helps soften both types of distress. After sleeping, memories of social difficulty typically feel less acute, allowing you to respond to similar situations in the future with greater equanimity. Your sleeping brain does not erase the lesson. It preserves what you learned while easing the hurt that accompanied the learning, like a bruise that fades while the wisdom of caution remains. Your social pain is gently tended by sleep. Reconsolidation is a remarkable discovery about how memories evolve. Every time you recall a memory, it enters a temporarily unstable state, requiring reconsolidation during subsequent sleep. This means memories are not permanently fixed once initially stored. They are dynamic and subject to gentle modification each time they are activated. In therapeutic contexts, this has promising implications. Recalling a distressing memory in a safe, supportive environment and then sleeping may allow that memory to be reconsolidated in a softer, less distressing form. Your memories are living things, not fixed recordings, continuously tended and updated through cycles of recall, gentle alteration, and sleep-dependent reconsolidation. Like clay that can be reshaped each time it is warmed, your memories remain workable throughout your life. Targeted memory reactivation is a gentle technique researchers have explored, where sounds or scents present during learning are reintroduced during sleep to enhance consolidation of specific memories. For example, if you studied vocabulary while a particular fragrance filled the room, encountering that same fragrance during sleep can strengthen consolidation of those words. Studies from 2024 show this technique works by reactivating the specific neural patterns associated with the original learning, providing your brain extra rehearsal time for that particular information. Your sleeping brain is remarkably receptive to gentle external cues about what to prioritize. Like a gardener who knows which plants respond to a little extra water, your brain responds to the right sensory signals during sleep. Stress hormones interact with sleep-dependent memory consolidation in nuanced ways. Moderate stress can actually enhance consolidation for emotional experiences, but persistent high stress disrupts sleep architecture and impairs memory. The timing of cortisol release matters as well, as this hormone naturally peaks in early morning, which may contribute to why late-night sleep is especially valuable for memory. Understanding this relationship helps explain why chronic tension is so harmful to memory function and why calming the mind and honoring sleep are complementary approaches to maintaining cognitive health. Like a string that produces beautiful music at the right tension but snaps when pulled too tight. Your stress system serves memory best when balanced. Emotional memories that are consolidated across multiple nights of healthy sleep undergo gradual transformation. What once provoked sharp distress slowly becomes a memory you can hold without being overwhelmed by it. This multi-night processing is not merely repetitive. Each night's REM sleep adds another layer of emotional perspective, slightly adjusting the weight and meaning of the memory. Over weeks and months, memories that seemed unbearable can become bearable, then manageable, then simply part of your history. Sleep does not erase pain. It gradually teaches you how to carry it, like a stone carried in your pocket that slowly wears smooth with time. Your difficult memories are polished by the patient hands of sleep. You are drifting beautifully now. Feel the gentle rhythm of your own heartbeat. That faithful companion who has been with you since before you drew your first breath. Each pulse is a tiny affirmation, a quiet whisper saying, "You are here. You are alive. You are safe." Let your attention float to your hands. Notice how they rest, open or curled, warm or cool. These hands have touched 1,000 things today, and now they are finally still. They deserve this stillness. Somewhere deep inside your brain, the emotional memories of this day are being sorted with extraordinary tenderness. The moments that made you smile are being strengthened. The moments that stung are being softened. Your sleeping brain is a healer who never charges, never tires, never forgets to show up. Allow yourself to trust this process completely. You have been held by sleep every night of your life. Tonight is no different. We drift onward together. Sleep itself unfolds in recurring cycles, each lasting roughly 90 minutes. Within each cycle, your brain transitions through distinct stages: light sleep, deep sleep, and REM sleep, each with unique characteristics and purposes. Light sleep, or stage 2, features brief bursts of rapid brain activity called sleep spindles, which research from 2024 shows are essential for shielding new memories from interference. Deep sleep, or slow wave sleep, is characterized by long, rolling brain waves and is when your brain performs its most intensive consolidation work. REM sleep, when vivid dreams unfold, is linked to integrating new memories with existing ones and processing emotional experiences. Throughout the night, you cycle through these stages repeatedly, giving your brain multiple opportunities to work on different facets of memory, like the movements of a symphony. Each stage contributes its unique voice to the whole composition of a night's rest. During deep sleep, something extraordinary occurs in your hippocampus. The very same neurons that activated when you experienced something during the day fire again in the same sequence, but much faster, compressed to up to 20 times their original speed. Scientists call this memory replay. If you explored a new path through a park this afternoon, the neurons encoding that journey will rehearse it tonight while you sleep, like your brain practicing the route in rapid miniature. Research published in Nature in 2024 reveals that this replay is not random. Your brain selectively replays experiences that were meaningful, surprising, or connected to something you value. Experiences that lack significance receive minimal replay time and are more likely to fade gently away. Like a pianist who practices only the passages that matter most, your sleeping brain rehearses what deserves to be remembered. Sleep spindles are brief bursts of brain activity that appear as distinctive patterns on brainwave recordings. These spindles, lasting only about half a second to 2 seconds each, occur hundreds of times across a single night during lighter sleep stages. Recent studies reveal that sleep spindles are deeply involved in memory consolidation, particularly for factual knowledge and practiced skills. When you learn something new during the day, the number of spindles you produce that night tends to increase, especially over brain regions connected to what you learned. Scientists believe these spindles help shield new memories from interference, while simultaneously weaving them into your existing knowledge base. Like tiny protective cocoons forming around fragile new memories. Spindles give each one time to settle safely into place. The transfer of memories from your hippocampus to your neocortex, the vast outer layer of your brain, unfolds primarily during sleep. Think of your hippocampus as a temporary notebook, hastily recording the day's events, while your neocortex is the carefully organized library where permanent records reside. Throughout the night, particularly during deep sleep, these two regions engage in a precisely choreographed dialogue. The hippocampus sends out patterns representing recent experiences, and the neocortex responds, gradually constructing permanent neural structures to house them. Research from 2024 indicates this transfer process can require weeks or even months to fully complete for some memories. Each night's sleep contributes another layer to this gradual migration, slowly weaving new experiences into the enduring fabric of your knowledge. Like a cathedral built stone by stone across many seasons, your permanent memories are constructed patiently, one night of sleep at a time. Your brain's waste removal system, known as the glymphatic system, operates primarily during sleep. Throughout waking hours, your brain accumulates metabolic waste as a natural byproduct of neural activity. During sleep, studies in animal models show the spaces between brain cells can expand significantly, allowing cerebrospinal fluid to flow more freely through brain tissue, washing away accumulated debris. Among these waste products is beta amyloid, a protein associated with cognitive decline when it builds up over time. Research from 2024 confirms that insufficient sleep allows these substances to accumulate, potentially interfering with memory processes and cognitive clarity. Sleep is not merely when your brain organizes memories. It is also when your brain performs essential housekeeping, clearing away chemical residue that could cloud tomorrow's thinking. Like a gentle rain washing dust from leaves so they can breathe and grow. Your glymphatic system cleanses your brain so it can function at its best. A recently explored area of sleep science involves thalamic gating, the process by which your thalamus, a relay station deep in your brain, regulates information flow during sleep. While you are awake, the thalamus transmits sensory information to your cortex for processing. During sleep, it partially closes this gate, reducing external sensory input and allowing your brain to focus on internal memory processing instead. Research from 2025 shows that the precision of this gating mechanism directly influences how effectively memories are consolidated. When the thalamic gate functions well, your brain can devote its full resources to overnight memory work without distraction, like closing the curtains so you can work undisturbed by the passing world outside. Your thalamus creates the quiet conditions your memory system needs. Selective consolidation during sleep means your brain does not attempt to preserve everything with equal fidelity. Instead, it extracts patterns, meaning, and general principles while often allowing specific details to fade gracefully. This process, known as schema consolidation, helps you learn general rules from specific examples. If you encountered several dogs this week, your brain may not perfectly preserve each individual animal during sleep consolidation, but it will strengthen your general understanding of what dogs are like. This prioritization of patterns over isolated details is usually beneficial, as it allows you to generalize learning to new situations you have never directly experienced. Like an artist who captures the essence of a landscape rather than copying every leaf, your sleeping brain distills meaning from detail. Sleep architecture shifts across the night in a way that serves different memory functions at different hours. Early in the night, you spend more time in deep, slow-wave sleep, ideal for consolidating facts and daily experiences. As the night progresses, you spend increasingly more time in REM sleep, which supports emotional processing and creative association. This natural progression means that even if you sleep only 5 or 6 hours, you will likely receive most of your deep sleep, but miss substantial REM time. Conversely, sleeping later into the morning provides extra REM sleep. Since later hours are REM-rich, different memory types benefit from different portions of the night. Like a garden that receives rain in the evening and sunshine in the morning, your memory system draws different nourishment from different hours of sleep. Your brain waves during deep sleep display a characteristic pattern of long, slow oscillations rolling across your cortex, like gentle swells on a calm ocean. These slow waves coordinate activity across different brain regions, helping to synchronize the dialogue between your hippocampus and neocortex. Research from 2024 using sophisticated recording techniques reveals that slow waves do not occur randomly. They are precisely timed to align with sharp wave ripples from the hippocampus and sleep spindles from the thalamus. This three-part harmony, slow waves, sharp wave ripples, and sleep spindles, all occurring in exquisite temporal coordination, creates optimal conditions for transferring memories from temporary to permanent storage. Like three instruments playing in perfect time to create a sound none could produce alone. This neural choreography unfolds while you are completely at peace. Synaptic homeostasis is the process by which your brain regulates the strength of its neural connections during sleep, throughout the day, as you learn and experience new things. Synapses strengthen and multiply. By evening, your brain is dense with connections, many of them redundant or unnecessary. During sleep, particularly deep sleep, your brain reviews these connections and gently weakens or removes the less useful ones, while reinforcing those that matter. Think of it as tending a garden, trimming back overgrowth so the valued plants can flourish. Research from 2024 shows that this pruning process is essential for maintaining your brain's efficiency and creating space for new learning tomorrow. Without adequate sleep, your neural garden becomes overgrown, making fresh growth more difficult. Like a sculptor who reveals the form by removing what does not belong, sleep shapes your brain by letting go of the unnecessary. Your circadian rhythm, your internal 24-hour clock, interacts with memory consolidation in meaningful ways. Even if you sleep during the day after working through the night, the quality of memory consolidation may differ from nighttime sleep because your circadian rhythm influences the neurochemical environment of your brain. Research shows that circadian disruption from irregular schedules or shifting time zones impairs memory consolidation, even when total sleep time remains unchanged. Your brain expects to perform its consolidation work during certain phases of its natural rhythm. Working against this rhythm by by sleeping at the wrong biological time reduces consolidation efficiency, like a tide that follows the moon, regardless of what happens on shore. Your brain's memory rhythms follow their own internal schedule. Recent research confirms that the quality of your sleep matters more than the total hours spent in bed. 7 hours of consolidated, uninterrupted sleep provides more effective memory consolidation than 9 hours of fragmented sleep with frequent awakenings. Each time you are briefly roused, even for moments you do not remember, your brain must restart its sleep cycle, potentially disrupting the consolidation processes that were underway. This is why conditions that cause frequent micro-awakenings throughout the night can severely impair memory, even when the person feels they slept for a long time. Continuous sleep allows your brain to move smoothly through complete cycles of processing work, like a river that flows most powerfully when unobstructed. Your memory consolidation works best when sleep flows without interruption. Astrocytes, star-shaped brain cells once thought to merely support neurons, are now recognized as active participants in sleep-dependent memory consolidation. Research from 2025 reveals that astrocytes regulate the chemical environment around synapses during sleep, influencing which connections strengthen and which weaken. These cells also play a role in the glymphatic clearance system, helping to flush waste products from neural tissue. The discovery that astrocytes actively contribute to memory processing has expanded our understanding of sleep as a whole brain phenomenon involving not just neurons, but the supporting cells that surround them, like stagehands working behind the curtain to ensure the performance proceeds smoothly. Astrocytes quietly enable the memory work that neurons perform. Scientists have discovered that sleep oscillations in different brain regions become more tightly coupled during memory consolidation. When a memory is being actively consolidated, the brain waves in your hippocampus, thalamus, and neocortex synchronize with remarkable precision. This coupling appears to create windows of opportunity during which information can be efficiently transferred between regions. Research from 2025 shows that the degree of oscillation coupling predicts how well a memory will be retained. The more precisely these regions communicate during sleep, the stronger the resulting memory. Like dancers who move in perfect unison because they are listening to the same music, your brain regions coordinate their activity during sleep to create memories that endure. Traveling waves of neural activity sweep across your cortex in organized patterns during sleep. These waves, visible in brain imaging, appear to coordinate activity across distant brain regions, helping to bind distributed memories together. Recent research shows these traveling waves follow specific paths connecting functionally related brain areas. During memory consolidation, traveling waves may help ensure that different aspects of a memory stored in different locations are properly linked. Your memory of a complete experience is not housed in a single location, but in many, and sleep maintains the connections that bind these scattered fragments into coherent wholes, like a current that connects distant shores of the same ocean. Traveling waves unite the far-flung pieces of each memory. Acetylcholine, a brain chemical essential for learning, shifts dramatically across sleep stages, creating different environments for different types of memory work. During REM sleep, acetylcholine levels are high, similar to waking, which may facilitate the formation of new connections and creative associations. During deep sleep, acetylcholine levels drop substantially, which appears to be necessary for the hippocampus to successfully transfer information to the neocortex. These shifting neurochemical environments across the night create distinct conditions suited for different aspects of memory processing. Your brain is not performing the same task all night. It is running different programs at different times, each optimized for a specific kind of memory work. Like a chef who uses different temperatures for different stages of a recipe, your brain adjusts its chemistry to suit each phase of consolidation. Melatonin, the hormone that signals your brain to prepare for sleep, may also play a direct role in memory consolidation. Research from 2025 suggests that melatonin does more than merely promote drowsiness. It appears to influence the timing and efficiency of memory processing during sleep by modulating neural activity in the hippocampus. People whose melatonin production follows a regular, predictable pattern tend to show better memory consolidation than those with irregular melatonin rhythms. This finding adds another layer to our understanding of why consistent sleep schedules support cognitive health. Like a conductor who sets the tempo before the orchestra begins to play, melatonin helps establish the rhythm within which your memory consolidation unfolds. The temperature of your sleeping environment gently influences memory consolidation. Your brain performs optimally when your core body temperature drops slightly during sleep, a natural part of your circadian rhythm. Studies show that sleeping in a cool room supports better quality sleep and more effective memory consolidation than sleeping in warmer environments. Excess warmth during sleep can fragment your sleep cycles and reduce time spent in the deep stages where intensive consolidation occurs. This is why uncomfortably warm nights often lead to restless sleep and a sense of cloudiness the next day. Like a delicate instrument that performs best at the right temperature, your brain's memory work requires conditions that are comfortably cool. Chronic sleep insufficiency creates a cumulative deficit in memory consolidation that compounds over time. Missing even 1 hour of sleep per night across several weeks can produce measurable declines in memory performance. Unlike some debts that can be repaid quickly, sleep debt accumulates and cannot be fully erased by a single night of extended rest. Research from 2024 shows that people who consistently sleep less than their biological need show progressive impairment in both memory formation and retrieval. The effects build gradually, often without the person realizing how much cognitive capacity has been lost. Like a slow leak in a vessel that seems fine until the water level drops critically low. Chronic sleep loss quietly drains your memory resources over time. The soft border between waking rest and early sleep is a time when your brain already begins gentle memory processing. In the minutes before you fully enter sleep, your hippocampus starts to become more active, and the neural patterns of recent experiences begin to replay at lower intensity. This transitional period, called the hypnagogic state, is when many people experience fleeting images or thoughts that seem to blend reality with imagination. Your brain is not waiting for deep sleep to start its work. It begins tending memories the moment you begin to release waking awareness. Like the first quiet notes of a symphony that begin before the audience has fully settled, your brain's memory work starts in the tender, drowsy moments before sleep arrives. Research from 2025 has shown that brief micro-arousals during sleep, moments of near waking that last only seconds, can selectively disrupt memory consolidation for the specific memories being processed at that instant. These micro-arousals are often caused by environmental noise, sleep disorders, or an uncomfortable sleeping environment. While you may never become conscious enough to remember these disruptions, they can interfere with the delicate timing of memory transfer between brain regions. Protecting the continuity of your sleep environment helps ensure these critical moments of consolidation proceed uninterrupted. Like a photographer whose exposure is ruined by the slightest vibration, your brain's memory processing can be disrupted by disturbances too brief for you to notice. Emerging evidence from 2025 suggests that your sleeping position may influence how effectively your glymphatic system clears waste from your brain during sleep. Studies in animal models indicate that sleeping on one side may enhance glymphatic clearance compared to sleeping on the back or stomach. Though human research is still developing, if confirmed, this finding would add a surprisingly simple factor to the list of things that support healthy memory consolidation. The physical position of your body during rest may quietly influence how well your brain can perform its essential cleaning work. Like water that flows most freely when the channel is properly aligned, your brain's waste removal may benefit from the simple geometry of how you rest. Notice how far you have traveled without moving at all. Your body is growing heavier now, settling deeper into rest, like a leaf floating slowly down through still water. There is no current pulling you. There is no destination you must reach. Only this gentle descent, this unhurried sinking into softness. Your brain has been working quietly this whole time, sorting, tending, protecting. You can feel it perhaps as a kind of warmth behind your eyes, a fuzziness at the edges of your thoughts, a sense that the sharp lines of the day are dissolving into something softer, something kinder. Your toes are relaxed. Your ankles are relaxed. Your calves are releasing their tension like snow melting from a rooftop in the first warmth of spring. Let the weight of understanding settle into you without effort. You do not need to carry these facts. They are already part of you, already being woven into the fabric of your sleeping mind. We are almost there now. Just a little further into the gentle dark. Memory is not a single object stored in a single place. It is a symphony of processes unfolding throughout your entire brain. When you recall this morning's first sip of tea, you are not accessing a video recording from one location. Instead, your brain reconstructs the experience from scattered pieces. Visual areas recall the color of the cup. Olfactory regions resurrect the tea's fragrance. Motor areas remember the warmth of ceramic against your palms. Emotional centers add the feeling of that first quiet moment. Research from 2025 confirms that each act of remembering is an act of rebuilding, weaving together threads from multiple neural networks. This reconstruction happens so swiftly that it feels like a single, solid memory. But it is more like an orchestra playing a familiar piece from memory, each section contributing its unique voice, like a mosaic assembled from countless tiny tiles. Your memories are wholes created from beautifully scattered parts. Your brain receives a staggering flood of sensory information every second, far more than conscious awareness can process. Researchers estimate that your conscious mind captures only a tiny fraction of this stream, perhaps less than 1%. This creates a quiet challenge. With so much arriving, what should your brain preserve? And what should it release throughout the day? Most sensory input passes through like water, through open fingers, forgotten immediately. But certain moments catch your attention. A stranger's unexpected kindness, the scent of rain after weeks of dry air, a sudden insight about something you have been wondering about. These moments are marked with neurochemical signals that whisper to your brain, "Tend to this one." Tonight, while you sleep, your brain will review these marked experiences and choose which deserve a lasting place. Like a curator selecting which treasures to display in a gallery of infinite rooms. Your brain chooses carefully what to preserve. Scientists recognize several distinct types of memory, each handled differently by your sleeping brain. Episodic memories are your personal experiences. Your 10th birthday. Your first day at a new place. The conversation you had this morning. Semantic memories contain facts and concepts. Knowing that water freezes at 0 degrees. Understanding what kindness means. Recognizing that the sun rises in the east. Procedural memories govern skills and habits. How to balance on a bicycle. How to type without looking at the keys. How to tie your shoes without thinking. And then there are emotional memories. Spatial memories. And working memories that hold information temporarily. Research from late 2023 reveals that different types of memories are processed during different sleep stages, with your brain running specialized tending programs throughout the night, each designed for a particular variety of information. Like a library with different sections for different kinds of knowledge, your sleeping brain files each type of memory in its proper place. The hippocampus, a small structure shaped like a seahorse, resting deep within your brain, serves as memory's first guardian. Every new experience destined for lasting memory must first pass through this region, which functions as a temporary holding area. Throughout the day, your hippocampus collects fresh memories, keeping them in a fragile, unstable state, like wet ink that has not yet dried on the page. Studies from 2024, using advanced brain imaging, show that the hippocampus is remarkably active during certain sleep stages, particularly during what researchers call sharp wave ripples, brief bursts of intense neural activity that occur hundreds of times each night. During these moments, your hippocampus replays the day's experiences at extraordinary speed, like watching your day unfold in rapid miniature within the sheltered darkness of sleep, like a faithful scribe who records everything during the day and then reviews the notes by candlelight each evening. Your hippocampus tends your memories with quiet devotion. Your brain actively decides which memories deserve long-term preservation, and this selection process relies heavily on emotion and relevance. Moments that sparked strong feeling receive neurochemical markers, particularly involving norepinephrine, that essentially tell your brain, this one matters. Similarly, information that connects to your existing knowledge or current pursuits receives preferential treatment. If you are studying a new language, words from that language encountered today will be prioritized over random details that seemed unrelated to your life. Your sleeping brain acts like a thoughtful editor, curating the story of your life by selecting which scenes belong in the permanent collection. Like a jeweler who knows which stones deserve the finest setting, your brain recognizes value and gives it the care it deserves. Different memory types require different sleep stages for optimal consolidation. Declarative memories, facts, events, things you can consciously recall, benefit most from slow-wave, deep sleep, when your hippocampus is most actively replaying experiences. Procedural memories, skills and habits, are consolidated primarily during stage 2 sleep, with its characteristic spindles. Emotional memories receive their special processing during REM sleep, where emotional intensity can be softened while informational content is preserved. Studies from 2024 demonstrate that selective deprivation of one sleep stage produces specific deficits in exactly the types of memories that stage processes. Your brain requires the full composition of sleep stages to properly tend all varieties of memory, like a complete meal that nourishes different parts of your body. A full night's sleep nourishes every kind of memory you carry. The timing of when you learn something influences which sleep period is most valuable for consolidating it. Information encountered in the morning tends to be consolidated during the following night's rest. But information encountered in the evening may begin consolidation that very same night. If you learn something just before sleep, your hippocampus can begin replaying it within minutes of your drifting off. This has led to the gentle study practice of reviewing meaningful information just before rest. Research confirms this approach works. Material reviewed right before sleep is often remembered more clearly than material reviewed hours earlier. Your brain essentially receives an early start on consolidation, processing these fresh memories during the first sleep cycles of the night. Like planting seeds just before the rain arrives. Learning before sleep ensures that consolidation begins at the earliest opportunity. Sleep before learning is just as meaningful as sleep after. Studies reveal that adequate sleep the night before you encounter something new makes a measurable difference in how well you encode it. When you are sleep deprived, your hippocampus shows reduced activity, making it harder to form new memories in the first place. It is like trying to write with a pen that is running dry. Even if the thoughts are brilliant, the instrument cannot capture them properly. A well-rested brain has been cleaned by the glymphatic system, has had its synapses properly pruned and organized, and is chemically and electrically prepared to efficiently record new experiences into neural patterns. Like preparing a canvas before painting, sleep readies your brain to receive whatever tomorrow will bring. Sleep deprivation impairs new memory formation more severely than memory retrieval. If you are tired and trying to recall something you learned while well rested, you may struggle somewhat, but can often still access the memory. But if you try to learn something new while sleep deprived, your ability to form lasting memories drops dramatically. Some studies show reductions of 30 to 40% or more. Your hippocampus shows measurably reduced activity after a sleepless night. People who stay awake all night before learning often perform worse than those who studied less but slept well. Not merely because they are tired during the task, but because their sleep-deprived brains cannot effectively encode what they are encountering. Like trying to catch water in a cup that has cracks. A tired brain lets new memories slip through. Memory formation requires a brain that has been properly tended by sleep. Learning a new physical skill requires a specific type of memory consolidation that unfolds during sleep. When you practice a movement, playing an instrument, perfecting a dance step, refining a sport technique, your brain records not merely the motions, but the subtle timing and coordination that make them fluid. Studies using brain imaging show that motor skill memories are consolidated during stage 2 sleep, particularly during sleep spindles. People who rest after practicing a new motor skill often show remarkable improvement upon waking, sometimes performing better than they did at their peak during practice. This sleep-dependent improvement happens without any additional practice. Your brain literally rehearses and optimizes the skill while you are unconscious. Like an apprentice who practices alone after the master has gone home, your sleeping brain refines your skills in private, presenting you with the improvement as a quiet gift each morning. The spacing effect. The finding that learning spread across multiple days produces stronger memories than cramming everything into one session depends heavily on sleep. Each night of rest after a learning session provides another opportunity for consolidation. When you revisit material after sleeping on it, your brain reconsolidates the memory, making it deeper and more permanent. Research suggests that memories pass through a temporary vulnerable state during reconsolidation, where they can be strengthened, updated, or gently modified. This is why sleeping between study sessions is far more effective than attempting to absorb everything in one exhausting marathon. Each sleep cycle adds another layer of strength to your memories. Like a blacksmith who heats and folds metal repeatedly to make it stronger, your brain tempers memories across multiple nights of sleep. Reconsolidation is one of the most surprising discoveries in memory science. Every time you bring a memory back to mind, it becomes temporarily unstable again, requiring reconsolidation during subsequent sleep. This means memories are never truly fixed. They are living, breathing structures, subject to gentle modification each time they are recalled. The memory you hold of a childhood afternoon is not the same memory you held 10 years ago, because it has been recalled and reconsolidated many times since. Each iteration subtly shaped by your current understanding and emotional state. Your memories are not photographs. They are paintings that are quietly retouched with each viewing, like a path through a forest that shifts slightly with each traveler who walks it. Your memories are shaped by every act of remembering. Working memory, the mental workspace that holds information you are actively using, depends heavily on sleep for its capacity. Research from 2025 shows that sleep deprivation can reduce working memory capacity by up to 40%, making it harder to hold multiple pieces of information in mind simultaneously. This affects everything from following a conversation to solving problems to making decisions. Sleep restores working memory capacity by clearing temporary neural clutter and refreshing the prefrontal circuits that support active thought. Like a desk that must be cleared each evening so it can be used productively the next morning. Your working memory needs sleep to restore its full capacity. Your brain distinguishes between implicit and explicit memory during sleep consolidation. Explicit memories are things you consciously know. Facts, events, information you can deliberately recall. Implicit memories operate below awareness. Habits, conditioned responses, skills you perform automatically. Research from 2025 reveals that these two systems are consolidated through partially different mechanisms during sleep, with explicit memories relying more heavily on hippocampal replay during deep sleep, and implicit memories depending more on cortical plasticity during lighter stages. Both systems benefit from sleep, but in different ways. Like two gardens tended by the same gardener using different tools. Your explicit and implicit memory systems each receive the specific care they require. After a day of intense learning, your hippocampus needs sleep to clear its temporary storage and make room for tomorrow's experiences. Without this clearing process, the hippocampus becomes saturated, reducing your capacity to encode new memories. Studies show that sleep-deprived people struggle to learn new information even when they are actively trying to focus. Not merely because they are tired, but because their hippocampus lacks the capacity to absorb more. Sleep creates space, preparing your brain to engage with tomorrow's experiences fully and openly. Like emptying a mailbox so new letters can arrive. Sleep clears the way for fresh learning. The synaptic changes underlying memory are physical and measurable. Learning strengthens connections between neurons by increasing the number of chemical receptors at synapses and sometimes even growing entirely new synaptic connections. During sleep, particularly deep sleep, your brain regulates these physical changes, reinforcing meaningful connections while gently pruning unnecessary ones. This is actual physical remodeling of your brain's structure, happening while you are completely unaware. The memories you will carry into tomorrow exist as specific patterns of synaptic strengths distributed throughout your brain. Sleep sculpts this physical landscape, literally reshaping your neural architecture based on what you experienced and what mattered. Like a river that slowly carves the valley it flows through, your memories physically reshape the brain that holds them. Sleep protects new memories from interference by later experiences. When you learn something and then immediately encounter similar but different information, the newer learning can interfere with the older, a phenomenon called retroactive interference. However, if you sleep between the two learning episodes, the first set of memories is consolidated and protected, making it resistant to interference from subsequent learning. Research from 2025 shows that this protective effect is mediated by sleep spindles, which appear to lock new memories into a stable state, like sealing a letter in an envelope before placing another on top of it. Sleep protects each memory before the next one arrives. During sleep, your brain extracts semantic knowledge from specific episodes, a process that transforms individual experiences into general understanding. If you read several articles about climate science today, your brain will not merely replay each article during sleep. It will extract the common themes, the shared conclusions, the underlying principles, and consolidate these as general knowledge that transcends any single source. This semantic extraction during sleep is how you build expertise over time, gradually distilling specific experiences into broad understanding. Like a beekeeper who transforms thousands of individual flower visits into a single jar of honey, your sleeping brain distills specific experiences into the sweet substance of understanding. Reviewing meaningful information just before sleep offers distinct advantages that researchers continue to document. When you engage with material right before rest, that information receives priority during the first sleep cycles of the night. Your hippocampus begins replaying these fresh memories almost immediately upon your falling asleep, providing extra processing time. Additionally, there is no interference from other experiences, as you encounter nothing new between studying and sleeping. The last things you think about before sleep receive special consolidation treatment, making the quiet minutes before rest an ideal time for engaging with what matters to you. Like placing the most treasured items closest to your heart before settling in for the night. What you hold in mind at bedtime receives the most tender care. The concept of sleeping on a problem has genuine scientific support. During sleep, particularly REM sleep, your brain makes novel associations between seemingly unrelated concepts. The relaxed, neurochemically unique state of REM sleep permits more flexible thinking than waking consciousness typically allows. Studies show that people frequently solve problems or experience creative insights after sleeping, especially if they engaged with the problem before rest. This incubation happens because your sleeping brain continues working on the puzzle while freed from the constraints and assumptions that limited your waking approach. Morning clarity feels sudden, but it is actually the product of hours of quiet processing, like a seed that germinates unseen beneath the soil before breaking through to sunlight. Your solutions grow in the darkness of sleep, before emerging into awareness. The prefrontal cortex, located behind your forehead, plays a special role in memory consolidation by organizing and indexing memories for future retrieval. During sleep, particularly deep sleep, your prefrontal cortex coordinates with your hippocampus to sort new memories into your existing mental frameworks, the schemas through which you understand the world. Recent research shows that prefrontal cortex activity during sleep predicts how well you will be able to access memories later. Strong prefrontal hippocampal dialogue during sleep helps ensure memories are not merely stored, but remain findable, properly indexed and organized so you can locate them when needed. Like a librarian who not only shelves books but maintains the catalog that helps you find them. Your prefrontal cortex ensures your memories remain accessible. Sleep deprivation affects the hippocampus with particular severity. Brain imaging studies show that a single night of total sleep deprivation causes measurable reductions in hippocampal volume and reduced activity. Chronic sleep deprivation leads to persistent hippocampal impairment, making it progressively harder to form new memories. Fortunately, this decline is not necessarily permanent. Returning to healthy sleep patterns allows the hippocampus to gradually recover its function. But during periods of sustained sleep loss, your memory formation abilities suffer significantly, creating a concerning pattern where poor sleep weakens memory. Worry about memory creates more sleep difficulty, and the cycle deepens. Like a plant that wilts without water but revives when watered again. Your hippocampus can recover when given the sleep it needs. Different individuals require different amounts of sleep for optimal memory consolidation. While 7 to 9 hours is typical for adults, some people genuinely need more, and others function well with somewhat less. Genetic factors influence both sleep need and consolidation efficiency. What matters most is consistency and quality. Getting sufficient uninterrupted rest on a regular schedule. Your brain adapts to your patterns, and irregular schedules disrupt its ability to anticipate when consolidation will occur. Finding your personal sleep need and honoring it reliably provides your brain the dependable consolidation time it requires. Like a musician who performs best with a consistent rehearsal schedule, your brain consolidates most effectively when sleep follows a predictable rhythm. Memory networks within your brain are not collections of isolated facts, but interconnected webs where related memories link to one another. Sleep strengthens not only individual memories but the connections between related ones, building increasingly rich semantic networks. This is why sleeping after studying often leads to insights about relationships between ideas that were not apparent during waking study. Your sleeping brain connects scattered dots, discovers patterns, and constructs architectures of understanding from dispersed pieces of information. By morning, knowledge feels more unified, concepts more connected, comprehension deeper. Like a constellation that becomes visible only when you step back far enough to see all the stars at once. The connections between your memories emerge most clearly after sleep. Transitive inference demonstrates that your sleeping brain actively reasons rather than merely storing information. If you learn that item A ranks above item B, and item B ranks above item C, after sleeping you will reliably know that A ranks above C, even though you were never directly told this. This phenomenon reveals that your sleeping brain is drawing conclusions, making logical connections, and building understanding that extends beyond what was explicitly presented. Sleep does not merely strengthen what you learned. It helps you understand implications you did not consciously grasp while awake. Like a puzzle that assembles itself while you are not looking, your sleeping brain completes patterns from the pieces you provided. We have traveled far together tonight through the hidden world of memory and sleep. We have discovered that your brain does not merely store memories, it actively protects them. From the moment an experience enters your hippocampus to the slow, patient transfer into permanent cortical storage. From the emotional healing that unfolds in REM darkness to the physical pruning and strengthening of synapses, your sleeping brain is a guardian of extraordinary devotion. The question, how does your brain protect memories while you rest, has revealed its answer across these 100 facts. Your brain protects memories through replay and rehearsal, through selective strengthening and gentle forgetting, through emotional processing and creative connection, through physical remodeling and chemical cleansing. Sleep is not rest from remembering. It is the time when remembering becomes most truly itself. And now, as these ideas dissolve softly into the approaching stillness, let everything you have heard tonight simply become part of you. You do not need to hold any of it consciously. Your hippocampus has already begun its work. Your sleep spindles are forming. Your slow waves are beginning to roll. Feel your body growing heavier, sinking into warmth and safety. Let your breathing slow to its deepest, most natural rhythm. Feel the boundary between your thoughts and the darkness around them growing softer, thinner, more permeable. You are not your memories, but you could not be yourself without them. They are the threads your sleeping brain weaves into the fabric of your being. Night after patient night, with a tenderness that asks nothing in return. Let your mind dissolve now into the vast, quiet space where all memories rest safely. There is nothing left to hold. There is nothing left to do. Only the gentle, ancient work of sleep, beginning once more, as it has every night of your life, as it will tonight. Your mind has traveled far. Now let it rest. Good night, sleepy soul.